Pins are non-threaded cylindrical fasteners that are inserted into one or more holes to fix a component's position, join components, or maintain alignment between them. Pins are used to attach gears, sprockets, and pulleys to shafts so that they rotate as a unit. In some cases, pins are used to fix shafts in housings to prevent end movement and rotation. A clevis pin is a cylindrical pin with a head at one end and one or more holes running through the diameter.
Single-hole clevis pin is typically locked in place with either cotter pins or hairpin cotters, to provide motion between components where great accuracy is not required. Adjustable clevis pins have multiple holes, allowing the user to choose the appropriate length. Excess length may be removed. Quick-release detent clevis pins are essentially a cotterless clevis pin, that feature a ball detent that depresses and springs up to hold the clevis pin into place. Used for assembly speed or where cotter pins are difficult to use. Grooved clevis pins are essentially the same as standard clevis pins, but feature an annular groove at the end opposite the flanged head. This groove allows for the attachment of a retaining ring or hairpin cotter pin.
A taper pin is a semi-permanent, cylindrical pin that has a slight taper along its length. Taper pins are often used on parts that require frequent assembly and disassembly. Plain taper pin is a solid cylinder that starts at one diameter and tapers through its entire length to a slightly smaller diameter. It is usually used with the small end diameter facing the ground, and the larger end pointing up. The threaded taper pin is used with a taper pin washer and shear nut, safe tied with a cotter pin, or self-locking nut, if undrilled. A pin punch is used to remove metal pins from a hole. First use a starter punch to loosen metal pin, then use a pin punch to finish removing the pin from hole.
Dowel pins, also known as straight pins, are the most basic pins. Dowel pins derive their holding power from friction. Plain dowel pin is a solid, typically cylindrical semi-permanent pin mainly used to locate machine parts in a fixed position or to maintain alignment. Tapped dowel pins are parallel pin with internal thread. Stepped dowel pins have two or more different body diameters. Roll pins have a body diameter which is larger than the hole diameter, and a chamfer on either one or both ends to facilitate starting the pin into the hole. So a spring is created as the pin is compressed slightly to fit into the hole diameter it is destined for.
Slotted roll pins are C-shaped when viewed end-on. Slotted roll pins resemble a hollow cylinder with a gap or slot along its length to permit compression during insertion. They rely on a single curve of metal for their strength. The slot of the pin can be smooth or toothed in a variety of patterns. Coiled spring pins are spiral-shaped when viewed end-on. Coiled spring pins have several windings or layers of material, much like a rolled newspaper. The layering provides coiled spring pins their strength. The thickness of metal involved is typically thinner than that used in slotted spring pins. The main roll pin punch is used in seating the roll pin and in driving it out of the hole. This punch is identified by its ball right in the middle of the face.
Grooved pins are solid pins with 3 swaged grooves at 120-degree pitch along all OR part of their length. The 3 grooves are pressed into the cylindrical body to expand its diameter to a size greater than its nominal diameter. When the grooved pin is driven into a drilled hole of suitable diameter, the material displaced by the grooving process is forced back to partially close up the grooves and lock the pin into place. Knurled pins are similar to grooved pins because they have serration around the nominal diameter of the pin. The knurled pin differs from the grooved pin while there are many serrations on a knurled pin. Also, knurled pins are typically roll-formed whereas grooved pins are swaged. Knurled section may have either a straight knurl, a helical knurl, or a diamond knurl configuration. The multi-crested design evenly distributes the retention force, making it the ideal pin for soft materials and thin cross-sections. Helical knurls have the additional benefit of turning the pin into the hole during installation. This assists material flow and hole alignment while eliminating knurl shearing and chips. A cotter is a pin or wedge passing through a hole, to fix parts tightly together. Standard cotter pins are also known as split pins. These have 2 prongs that can be inserted into the hole of Clevis pins or other fasteners, one prong slightly longer than the other so they're easy to open, and bent outward to secure them in place. Hairpin cotters, or R-clips, are a spring-type cotter made to be reusable. Hairpin cotters are generally meant to be used in through holes. A coil gives a stronger grip than standard hairpin cotter pins, to prevent accidental release. Hairpin clips are generally meant to be used on a groove. Clip these pins onto grooved shafts and clevis pins, with retaining ring grooves to keep components in place. An extra loop locks these cotter pins more securely than other pins, so they can't vibrate out or be knocked off. The bow tie locking cotter works like a hairpin cotter but locks itself on. The double head design lets you push or pull these pins from either side of the hole. Once in place, there's little chance they will be vibrated out or knocked off. Hammer set cotter pins are used for parts that spin or are otherwise difficult to access. Slide these pins in and tap them with a hammer for a temporary hold. Reposition work, then bend the prongs outward to secure. Wedge lock cotter pins are heavy-duty pins. Slide these pins into the through hole in a clevis pin, then hit them with a hammer to wedge the prongs open.